Hi everyone, I'm Won-Lee. We now reach to sample theory. It is very important in statistics for you to understand statistics properly. Okay, that's why I'm glad to lecture this part, chapter 3. Okay, let's see what is a theoretical sample. Chap.3-1, theoretical understanding of a sample. Understanding samples correctly is very important since it is a starting point for understanding statistical theory. Chapter 1, organizing data, we explained the most of the data we have is a sample. Okay? Data, you have data, then that is a sample. We represented that data, the sample, with the lowercase letter x. X1, small x2, small xn, right? It is observed values. If you understand a sample only in this way, then you cannot properly understand statistical theory. It is necessary to know the theoretical background of a sample. Let's see. If you understand distinction that the uppercase X, capital X, represent the random variable and the lowercase x represent a specific value, then you can denote samples as uppercase X's, capital X1, capital X2, capital Xn. You have to understand this notation and meaning. Okay, let's say there is a population X, population. Population can be denoted by random variable X. If you have a random variable, then that variable has some probability distribution function, f of x, right? So let's see this way. In many random variables, it is a sample. Still, the values of x's are unknown. But when you observe data, then small x1, small x2, small xn is realized specific value, okay, of capital X1. This one is small x2 is observed value, realized value of a capital X2, like that. So let's see. They are x, x, x. How many? N many, N many. This is the, I think, initial concept of sample starts from here, but it is not convenient, right? This, okay? So add subscript 1, 2, small n. Oh, it is simple, like this. This is a theoretical sample you have to keep in mind, okay? This means x1, x2, xn, n random variables tilt follows IID f of x. What is it? IID. IID is abbreviation of identically, independently distributed f of x. The subscript 1 to n subscript are meaningless. It just represents a sample. So you may ignore this one, okay? Then what? Identical, x, 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 x. Independent, they are independent, okay? When you get data, small x1, x2, xn, I said they are independent. So they are n independent observed values here. Same thing here. Independent. Samples are independent. Okay? Otherwise, we have a big trouble to follow statistic theory. I think the statistics haven't exist in the world. Independence is that important. If they're dependent, no statistical theory, I think. That's why. So I said subscript 1 to n can be ignored, then x1 follows what? F of x. x2 follows f of x. xn follows f of x. You understand that? This notation and the meaning of this line, it is important. Okay? Okay, next. Let's see again. Parameter and statistic. Statistic is common noun. An unknown value of a population is called parameter. And any result obtained from a sample is called statistic. A statistic said to be a function of a sample, i.e., this means just a function, okay, not probability distribution function, just a function of x1, x2, xn. So x1 minus x2 is a function of a sample, okay, or f x1, small x1, xn. So this is a random variable. If you have the result of a function is small x1 minus x2 is a value, some value, okay? There is a population, size, capital N, or infinity. There's so many data here, unknown values. And we know there is a mean mu, variance sigma square, also unknown, because you do not know the values in the population. So we call them parameter. Sample. This is a theoretical sample. They are how many? Capital N many. But size small n, sample size, x1, x2, xn is a sample I told you, right? And we can get x bar, capital letter, s square, okay? Then we call them statistic. X1, capital X bar is what? Summation capital X divided by N. S square is like this. But when the values realized, sample values realized like this, we call this sample also, okay? Sample size N, there are real values here, X1, X2, Xn. We call them sample, and from here, we get small x bar, small s square. We call them statistic, okay? Statistic. Statistic is a function of sample, like this. Unfortunately, there are many textbooks that do not adequately convey the theoretical fundamentals of the sample. I dare to say the reason why statistics is often perceived as difficult is that many textbooks do not distinguish between capital X, lowercase x when explaining samples, and you know that next chapter, hypothesis test and ANOVA, that many statistical analysis methods, they do not, many textbooks do not distinguish big X, small x. Confusing. I cannot understand that. Why? If you do not learn about the theoretical sample accurately, like this sample, this is also sample, okay? While studying statistics, you become challenging to grasp the system of statistics framework. You cannot understand easily. If you study hard, you repeat the statistics many years, then you just like understand statistics, but in a fog, I think. Okay, sorry about that. Anyway, it is a real phenomenon. Okay, thank you. Bye.